In this video, I will solve this basic system of equations. Now understand that this cubic polynomial is likely a graph that looks something like this. All right, this is your classic cubic. Meanwhile, y equals 2 is a horizontal line. So the solutions would be the points of intersection. So this graph can have up to this system rather has up to 3 solutions, and we're looking for those points of intersection. So the way we can do that is by substitution. So if y equals 2, then I could take 2 and substitute that in for y. So that's going to make this polynomial become 2 equals x to the third power minus 2x squared minus 3x plus 2. Now I really need to have 0 on one side to be able to do these problems, so the first thing I would do is I would subtract 2 from both sides. So that would give me 0 is equal to x to the third power minus 2x squared minus 3x. These cancel out, I got nothing. So now it's a matter of solving this equation. It's bugging me that 0 is on the left, so I'm going to go ahead and put it over here on the right. Now, there is a common factor here. All of these terms have x. So I would pull out that x before I went any further. That would leave x squared minus 2x minus 3. Then I would see if I could factor this. X squared will be x times x. 3 can only be 3 times 1. Inner plus outer equals middle. Inner, I have 3x. Outer, I have 1x. I'm trying to get a middle of negative 2. So I need a negative 3 and a positive 1. So that would go like this. And negative 3 times 1 makes negative 3. So now that I have factored the polynomial completely, I can find my solutions by setting each one of these factors equal to 0. So over here I have x equals 0, x minus 3 equals 0, that's an ugly 3, and x plus 1 equals 0. X equals 0 is a solution. Adding 3 to both sides, I get x equals 3. And subtracting 1 from both sides, I get x equals negative 1. Now, the difference between just solving an equation like this one and solving a system of equations like I had to begin with is that the solutions of a system are ordered pairs, x's and y's, not just x's. Okay, so I need the y values that go with them. Now this problem is particularly simple because of the second equation. So what I like to do is I like to make a t-chart. So I have these 3 x's. So I have 0. Well, you know what? Let me put them in order. I have negative 1 and 0 and 3. I need the y values. Now I could either plug these into this top equation, or I could use the bottom equation, which is way simpler. Y equals 2. Guess what? That means all of these y values are simply 2. So these are the solutions. Negative 1 comma 2, 0 comma 2, and 3 comma 2. So the way the question was actually asked, which of the following is not a solution of the system? 0 comma 2, that's right there. Okay. Let's see. Negative 1 comma 2, that's right there. 3 comma 2, that's right there. So that just leaves D, 2 comma 3. That's the only one of these that is not a solution to the system.